Hey, good morning. At this point, this lesson was given already. At the time, we were experiencing some load shedding. So at this point, we are busy factorizing the difference of two squares. Okay, so if you need the full lesson, you'll find it in the description box below. Okay, so all of those were explained. So we're looking at the examples on page 19. The question says factorize. Okay. So this is the factorization of difference of two squares. So what do we need to know? We'll notice that on either side of the negative we have perfect squares. So the square root of a squared is a, the square root of r squared is r. So if that is the case, the first term and the second term are perfect squares with a minus between it, we can then use the factorization between two squares. So that would simply be a1 plus 1 minus r and r. Again, we need to factorize 9a squared minus b squared. What's the square root of 9a squared? It's 3a. The square root of b squared is b. So yes, both are perfect squares and there's a negative between it. We can factorize. So that will be 3a plus b and 3a minus b. If you have written 3a minus b and 3 times 3a plus b, it means the same thing. You won't lose any more, so equivalent solutions there. Now we're looking at example, the fourth example and third example on page 19 for exercise 1.30. The question is to factorize 9a squared minus 25b squared. The square root of 9a squared is 3a. The square root of 25b squared is 5b. There's a minus between it, so yes, difference of two squares can be applied. So the square root of 9a squared is 3a, 1 plus 1 minus. The square root of 5b squared is 5b and 5b. Okay. Example 4. Again, we got 81c squared minus 49a squared. The square root of 81 c squared is 9c, the square root of 49a squared is 7a. And yes, there's a minus between it. The difference of two squares can apply. So the square root of 81c squared is 9c, 1 plus 1 minus. Square root of 49a squared is 7a. Okay. Let's carry on. Next one, example 5 and 6 on page 19. So the square root of 1 over 81 is 1 over 9. The square root of x squared is x. Yes, difference of two squares is evident there. So your square root of 1 over 81 is 1 over 9, 1 over 9, 1 plus 1 minus x and x. Looking at example 6, as you can see here, the square root of 2 remains square root of 2. There's 1 comma 4 1 something. So that's an irrational number. Okay. Other than that, we also know that common factors will override all type of factorization. As you can see, 2 is a common factor there, which was done in exercise 1.9. So that will give us x squared minus 16. Okay. So if we look at the bracket, as you can see here, the square root of x squared is x, the square root of 16 is 4. There's a minus between it, so the difference of two squares can be applied to the bracket. So I'm left with x and x. 16 is 4 and 4. 1 plus the other minus. Okay. That's the example 6. This is the example 7 for this exercise. Yes? The example 7 and 8. On page 13 for exercise 1.30. The square root of 81c squared is 9c. However, the square root of 49 into d minus e squared, the square root of 49 is 7, the square root of d minus e squared, that will cancel, basically you leave with d minus e. So with that in mind, okay, the square root of 81c squared is 9c. 9c, 1 plus 1 minus. The square root of 49 is going to be 7 into the square root of d minus e squared. This is d minus e. It's going to be d minus e. Okay. So remember in this factorization, we never have a bracket in the bracket, so we get rid of the bracket there. I made a mistake, I suppose I have written 7. Okay, so that is going to give you 9c plus 7d minus 7. Okay, then we have 9c minus 7d plus 7. Okay, let's look at example 8. We got AB4 minus, again we know that common factor overrides all type of factorization. So we got a as a common factor, b4 minus 1. B to the exponent 4 minus 1. So again, as you can see here, what's the square root of b4? Is b squared. Square root of 1 is 1. So yes, the difference of two squares can apply. However, that had to be a plus, you couldn't have applied that rule there. Okay. So that will give us b squared plus 1 and b squared minus 1. As you can see here, the difference of two squares can be applied on the second bracket, not on the first because of the positive. So I got a into, this must be written down, because that's still part of your factors. So that would be b plus 1 and b minus 1. Okay. That brings us to the examples for exercise 1.4. So I'll stop the video at this point. The full lesson to this can be found in the description box.